Hey everybody, and happy Friday. Welcome to live stream number 27. Today is July 14th. Man, it's Friday. We made it. That is awesome. Just gonna wait a couple of seconds here till we get some people in on the live stream. Hope you had an awesome week and ready to kind of like wrap up the week here. So I can see we already got a couple of people in here. That is awesome. Really appreciate it. We got Isaac in here. Awesome. Today's topic is the threads wrong in Fusion 360. So we're going to get in and we're going to talk a little bit about how you can create threads inside of Fusion. We're going to take kind of like a look at that. But before we get to that, as we have people trickling in here, thank you so much for taking the time to join. Down in the description area of this video, you will find my email address. And, I would really appreciate if you would send me a quick email with any kind of future topic you would like to see us do here on the live stream. These live streams are about, 20 minutes to a half an hour long, a little bit off the cuff here and just kind of like trying to add a little bit more value. All right. So I can see we already got 20 people. That only took 1 minute. That's awesome. So I think we should kind of like dive into today's topic. So, happy Friday, guys. So, like I said, today's topic are the threads wrong in Fusion 360. So, a little bit a while ago, I gotta set this up, right? I got a email from somebody who had tried to 3D print some of the threads that Fusion 360 creates, and was kind of questioning if they might be right. Now, I could possibly have reached out to somebody on the development team and kind of like asked them where the data comes from when you're creating threads inside of Fusion 360. But first of all, I really didn't feel like bothering them. They would probably come back with some kind of a, high-level answer that maybe I wouldn't understand. And then I had like my old mentor, Don Coleman, kind of like barking in the back of my head that, well, don't take somebody else's word for granted. If, check them yourself. And I thought, you know what? I have made a couple of threads on a lathe in the past, and I have my good old trusted machinist handbook. So I was thinking, why don't we do that? Let's go in and kind of like check that out. Let me just check the chat here. I can see that we got 32 people in here. I really appreciate it. We got Texas, we got Spain, Amsterdam. Really appreciate you guys taking the time to join. So, happy Friday, everybody. Let's go in and take a look at some threads inside of Fusion 360 and how we could actually check to see if they're, are they right or not. So, inside, I'm going to find my mouse. Inside of, and I'll get back to the chat later. We got England in here. Awesome, Luke. Can't wait to watch the Formula One race tomorrow. So inside of Fusion, go Hamilton. Inside of Fusion 360, in here. So let's go in and start. I'm gonna start a sketch, and I'm gonna try to do this quick because this is gonna be maybe a little too technical. I don't know. We're gonna do standard, so English or American, and then we're gonna do metric afterwards. So let's go and start a sketch here. We are in inches, and first of all, I'm just gonna do a circle here, and I'm gonna create a 0.25. So I'm going for a 1/4 thread. So 0.25, and we're gonna say Q, and I'm gonna make it an inch long here. So we have like this cylinder. 1/4 inch diameter, 0.25, 1 inch long. Now in here we can apply threads, right? So I go in here and apply the thread, and when I select the face, Fusion is smart enough to start looking at what kind of diameter we have. And of course what I'm going for here is the modeled portion where Fusion actually models it up right there, which is absolutely terrific. So let me just quickly run down these dialogues box. So what we're doing is we're doing a 1/4 UNC, and all this stuff is very important, of course, for doing all this stuff. So that's the type of thread we're going to create. Now you will see down here there's different classes. So there is a 1, 2, and 3. And that is kind of important. So A3, so let me just talk a little bit about this. So this is maybe something we should talk a little bit about later on too. And that is tolerances. And we're actually going to touch about that a little bit in this video here. And I really don't want to get too technical, but I'm thinking that, you know, some people would definitely benefit from this. I hope. Well, I hope. So there's different classes: 1A, 2A, 3A. 1A is kind of like a very rough type of thread that is not very accurate, like low end kind of thing. A2 is most, I would think, without knowing 100% sure, that is what you normally buy. If you're buying a set of bolts, it's a 2A. A3 is more like for high precision, so for inspection and so forth. And this is why you know, the machinery handbook here. We're going to talk a little bit about this one a little bit later. Is really handy because it got all that different information inside of there. So I'm going to leave it at a 3A in here. So there's going to be like the higher level in here. So I'm going to say okay to that, and we get the screw here. By the way, for you Europeans who don't know too much about standards, I don't know if you care or not, but quarter 20 means that it's a quarter in diameter, so 0.25, and then there's 20 threads for an inch. So if you went in here right now and you counted each thread, you should count 20 because we made this one 20 inches long. That's what quarter 20 stands for. All right. Because we're going to measure this one up, we are going to cut this one in half. And I just want to show you a cool and neat trick here to cut this one in half. I'm going to turn my origin on. And if you look here, you'll see I have a plane that cuts right through that screw we just created here, because it created right on the origin. Here's a neat trick if you didn't know it. Go into the Modify, go Split Body. It's right under the Modify tab. Split Body. Click on your body, and then select what you want to split with or cut with. What's going to be that plane. Boom, I just cut that one in half. That was easy, right? So if I go into the bodies folder, you will see I now have two different bodies in here. And I can just get rid of one of the bodies because it's easier to do this with like kind of like a section view. So now I just cut that screw in half. That was pretty easy, right? All right, so let me open up a sketch on this face here, because now we're kind of ready to and I want to lay the thread down, turn around. So now we're actually kind of like ready to start inspecting what do we got here inside of Fusion where we create these threads. So there's a lot of different ways to check threads, and I am not gonna put myself up and tell you that I am the master of the master. So if there's somebody out there who has a better solution or anything, you know, please add it down in the description area in there. But let's go in and look at how you would do this. And the way you normally do this is you will use cold wires to measure this. So a round pin, you will use 3 of those to measure with. So what we're actually going to do inside of Fusion is we're going to draw those pins up and kind of like take the measurement of that. So I'm going to start out by creating just a circular sketch to resemble the pin right in here. So I'm going to select a 3-point circle, and I'm going to go in here and just place a couple points here, and then this circle here, of course, it will be tangent within here, so it kind of lays like that. And I will say I have seen some people just use one wire, and what you do is you take your micrometers and you measure from the top here of the wire. And I've seen people just not putting 2 other wires in it, just do it flat in here. I really don't recommend doing that, because as soon as you do that, now you're relying on the diameter of this part. And what we're really trying to measure is the thread, right? Like if you're thinking about any screw that you're screwing into something, like at least in machining or something like that, you don't really, the diameter never touches anything. It's all about, you know, the location in here. So don't just go with one wire, use 3 wires for this. I guess that's what I'm trying to say. So I'm just going to place 3 other wires in here, or 3 other wires, or 3 other circles, because that's what we resembles. So I'm going to place one over here, like that, and one over here, like that. And they're going to, of course, be tangent too. So they're going to go in here, like that, and one's going to go to there. One's going to be tangent there, one's going to be tangent there. And then you're actually using the same size wires for all 3. So we can make these equals. And by the way, when you buy a thread wire gauge set, it comes in sets of 3. So what you do is you're now putting your mechanometers and measuring up on top of these 2 wires, and then this one down here for people who don't know this. So we are now tangent to the thread, and that's kind of like how we determine this. Now, just to make it a little bit easier to measure, I'm actually just going to place a line up here on top so we have something to measure with right there. Okay, that's good. Hope this is cool. So now what we have to do is we actually have to start doing a little bit of math, right? So now we got to determine in here what the 3 wires size is going to be, because that's going to depend on what kind of thread we're using. So I did this, and hopefully it's not going to confuse too many people. Look, let me just move this out of the way a little bit. I just put it in a Word document, and this is all stuff you can find like inside of the Machinist Handbook. And I hope that I'm not getting too, if you're watching the recording after this, you can always stop and you can grab a screenshot of this or something. So what we're going to do is we're going to come up with the wire size we're going to use. And the best wire size is 0.57735 divided by N, what is the thread per inch. In case of this one here, it was 20, right? Quarter 20. So it would be this 0.57735 divided by 20. Now, it says here best wire size, and it's actually because you can change this 0.57735 to either the high end is 0.101 or the low end is 0.050551555. So you can swap this number out with one of these 2 numbers down here in the range. And the reason for that is that when you're buying this thread wire set, I said they come in sizes or in 3 pins in each, but they're not like gauge pins. If you ever like dealt with gauge pins, they all come in like small increments. You don't do that with these thread wires. They come like in sets of different sizes. So they give you this range, but you're gonna adjust in the next formula, so it doesn't really matter. But that's just what best wire means. We can go here with best wire because, well, we're on a computer screen. Everything in here should be perfect. So let's use this one. So I'm going to call up my calculator here, right? My trusty calculator, and I'm going to do 0.57735 divided by 20. And I wanted to do this live because, well, this is live, right? This is YouTube live, so I felt like we had to do this live too. So this is the diameter of our pin. So let me do a Control-C to copy that. Go back into Fusion and do a diameter here. And since I made them all equal, I can just paste it into this box. Bang. Now we got the right wire. Okay, so with the right wire in here, now we're actually ready to do a measurements in here. Now, so we can go up here and measure here and hit measure. I wanted to make sure you saw this. In here in the measure command, there's something called show snap points. Now, if I turn it off for a second, if I go up here and I can select this line, and I go down here and select this circle, it measures from the line what is perfect, but it's measured to the bottom of the circle. I actually want, the outside of the circle. Well, if you turn on snap points, you'll actually see as I hover over the line, it actually also finds the midpoint, what is fine, whatever. But here's the cool thing. When I go into the circle, I hope it's to see that I actually get points that appears around all the different points. And just like when you're using joint inside, if I hold down Control or Command on your keyboard, if you have a Mac user, I can zero in on it there and I can measure it there. Okay, so measure, that was just kind of like me getting off topic, but the measurement over the 2 pins with the right measurement is, well, you can see it right here, 0.25683. So that is the number we are measuring in here. Now, let's get our formula back, because now we actually got to confirm that, of course. And that measurement is M, measurement over wires, should be the diameter of our thread plus the 3 pins minus 1.5155 divided by the thread per inch, what was the 20. So let's get our calculator up again, and let's do that. So we're going to do the diameter, and the diameter was what? Well, the diameter was 1.25 plus, and then we're going to do a little bracket here, and we're going to say that we're going to do the 3 times the diameter of the pins, what was that 28 thing there, minus 1.5155, right? Am I doing this right? Divided by 20. And we get 0.2608. Well, wait a minute. Let me just measure that again. So from here to, whoops, to here. I got, the result should be 0.2608, and the result is actually 0.25. Okay, well, let us just try to subtract those from each other. So if I say, click here, and I say minus 0.25683, that actually gives me 4 thousandths that it looks like it's off. But it actually isn't. Because one of the things we got to talk about when we are talking about doing threads is tolerances. Now, so this is where my trusty machinist handbooks come in. I'm not going to try to, I can show you how small the letterings is in here. It's extremely small. So you got to either get your own or try to or trust me, one or the other. So a thread, a 1/4-20 thread, actually has a tolerance on the diameter. So a 1/4-20 UNC, that's the one we got, and we picked an A3. What was the gauge pin size, or the high accuracy one? It has a max diameter of 0.25. The max, that's the max. It has a minimum, I'm going to subtract the minimum from this, what is 0.2419. That is 8 thousandths tolerance on this thread. Well, if we divide that in 2, that looks very suspicious to our 4 thousandths that I was just off when I did it on the screen. Oh, you couldn't see the screen, see? You couldn't see I did the calculation. Oh, I knew I was going to forget this. So, the max is 0.25, and the minus is 24.19. That's 8. Half of that is 4 thousandths. That's actually our, what it seems like we're out here. Here's something that is really cool. Check this out. If I go back into here, now, all of you guys watched that I made this, well, some of you guys watched this, and you saw that I made it 0.25 in diameter of the cylinder all the way back in the beginning. Well, if I go in here and I make a measurement from this corner to this corner, turn on our XYZ, look at in red, maybe hard to see, well, you can see it over here, delta X. What fusion does is that when you take, in this case, 0.25, and you extrude that cylinder out, and when you throw that thread on it, it automatically places diameter right at nominal, right at the in between the tolerance. Because if you were going to machine this thread in real life, I can again hear my mentor Don Coleman in the background. Place it in the middle of the tolerance, right? That's the best thing to do. I want to do a live stream later on where we talk more about tolerances, but let's just jump back in and redo this calculation then. Because if I go in here now with that knowledge, and say, okay, so it's actually 246 in diameter. It's actually the nominal. Remember, we're not measuring the outside of the we're measuring the pitch diameter, the important for the thread. And if I now say plus 3 times the diameter of the pin, right? Whoops. Like that, minus, and now I gotta get my formula back on, minus 1.5155 divided by 20, what is our fret per inch, then the result is 0.2568. Let's go ahead and check this again. Turn delta off. I hope you can see this. 0.25683. 0.2568 and round up to 3. So Fusion is actually right compared to the machinist handbook here, placing it right in the tolerance. Now this was 20 minutes. I hope that this is useful, guys. Looking in the chat here, I can see a couple of people. Nice to meet you all in there. I hope this is useful. 60 people in here. Let's do a quickly one on metric, because I know I have a lot of people out there who are from other areas, and learning. Repetition is key. So you just get this whole thing one more time. So let's get out of our measure command and let's just quickly do. Let's do one in metric. So I'm actually going to switch right here inside of Fusion. Switch over to millimeters. Hit OK, and just start a new sketch. And I want to do it on the kind of like the same plane as I did before. Do another circle, and I'm going to place. Let's do an M8 like this. And the only thing I have to make sure of is it's vertical, because I'm going to use that plane to cut it in half. Right there. Let's extrude that up. And the length here doesn't. Whoa. The length here doesn't really matter. Let's make it 35, whatever. It's a little bit bigger screw. I think it's bigger in Europe. Is that United States? I don't know. So, it's Friday, man. What can I tell you? The last live stream of the week. So let's go in and add a thread to that one. And I'm selecting that same face. And you will see again, I'm going to check modeled. And you will see that it already know that it's an M8, and here it does a pitch of 1.25. And you also in here have these different tolerances or classes in here. So like that, let's cut this one in half. So again, modify, split body. This thing, I should do some live streams of split body and split face. Those things are awesome. So I'm going to select my M8 and split it through the center right there. Hit OK, find out which one I want to keep. I think I'm going to delete this one. Right click, remove, and then I can start a sketch on that one. And again, I like to lay it down. Now let us just do one thing first. We know it was M8. So if I go into measure here and I select this corner to this corner and turn on my delta, you will actually see again Fusion brings it within the metric tolerance in here. So again, just like of course in the standard, there is a max and a minor, and a minor tolerance diameter. So we got that one. So that we got to remember that when we're using our calculation here. So let's place a couple of wires on this one. So again, I'm going to go ahead and use the 3-point circle, and I'm just going to select this one here. And I'm gonna do, if I did this one, then I'm gonna do this one. I want to make sure I don't snap to the midpoint. Okay, so there's our 3 wires. Let's add some tangency to them. So this there, this one there, and this one goes over here like that. Like I said, this is, I guess this might just be, I'm gonna make them all equal. You know, the machine is the way of checking your threads, but that's how I've always done it. All right, so now this is metric, we got to find out what wire size we need for this. So let's bring up our formula here. Now the metric one is just as easy, and it's actually all the same numbers. The only difference is instead of dividing by the thread per inch, we're just times the pitch. So that's kind of easy. So our calculator back on, and the first one up here is 0.57735, and times the pitch, what is on this M8 was 1.25. So that is now our pin diameter. So Control C for copy, D, and let's place that dimension like that. So now we got those wires. I'm just going to create a line over. It makes it a little bit easier to when we do our measurement. So like that. Okay, and then let's go in and do our formula again. So I just gotta go in here and check what was it again that the actually number for the overall, instead of 8, is actually 7.866. So 7.866. Oh, let me bring the formula over again so we can all look at it. So now I'm down here, plus 3 times the pins, what was that number, minus 1.5155, right, this number down here, times the pitch, what was 1.75, and there. So that's what we're supposed to measure over these pins. So let's go back into the measuring tool, grab that one and that one, turn the delta off. So that's the distance. Let's just check it. So 8.1366668. But think about, we're in metric right now. So right down here, this decimal calculation here, I'll take that one, right? So that's how you would check that to be able to check the threads. Now, we're coming up on a half an hour, so I want to end this. Before I do that, I did bring in the MagMaster card. So remember that inside of Fusion, you can also insert your MagMaster card components. And I did go in and I brought in a normal socket head cap screw and did the same calculation of it. And what I found with that one, because that's a model that MagMaster card provides, right? That's their model. We just bring it in. That one was not in the nominal tolerance for, I did a 1/4 inch 20. That was right on top of the major diameter, the 0.25. But all the calculation was right for that. So it was intolerant. So it's still good. It's on the high end of the tolerance, right? It's not on the nominal like Fusion does it. What will be right in the center of it. So that's, but it's still right. So to go back to the original point about, are the threads right in Fusion? Well, according to this, if I was going to inspect this on the shop floor, I would say yes, they are absolutely right inside of Fusion. I hope that some of you guys maybe had never seen how to measure a thread and maybe got some, now you know something. You can use that piece of knowledge to whatever you want. But that was what I was planning on showing you. I'm just going to check inside of the chat quick and just see. We got 53 people in here. I can see that a couple of people is going to choose to watch the video a little bit later. Love that. That's cool with me. It's going to be up. That's a cool thing. It's going to be up on YouTube, right? That's a great thing about the recording. And don't forget that in the description is my email address. If there's any topics you would like to see in the future, go ahead. So I really hope that you guys got something out of this. If there's any of you guys who have something to add to this, any piece of knowledge or whatever, put it down in the description area. Share the knowledge. That's what I kind of believe in, right? So I think I'm going to do, since it's Friday and we made it through a week, I think I'm going to end the broadcast as normal, but I'm going to jump into the chat and say hi to you guys and just see what is up. So, happy Friday, everyone. I hope that you have an awesome weekend. Thank you so much for taking the time out of your busy day to tune in. Let me know, if you like these, thumbs up. If you don't, hey, be honest. Put the thumbs down. That's fine. So I hope that I see you next week. Take care, guys.